In today's video, we are going to talk about plotting and naming points in polar form being new to you. So you're used to this rectangular coordinate system that has an x-axis and a y-axis, and you end up with ordered pairs x comma y. Today we're going to talk about this polar coordinate and this polar graph and the polar coordinates and how you plot points on there. So let's take a look at this case of Steve, who is trying to get to his cabin. Okay, so his cabin's up here, he's down here. He's got two options that we're going to take a look at today. One is driving to his cabin on the roads, and then the other is that he could hike to his cabin. So the driving is going to represent our rectangular coordinate or our rectangular point movement, and then his hiking to the cabin through the woods right here is going to represent a polar coordinate. We're going to talk about how to describe this path to send us straight to Steve's cabin using polar points. So let's take a look here at the rectangular and get into the polar points. So if we're doing rectangular, that's going to be talking about his driving path. So he can only go in straight in vertical or horizontal movements. So he's going to drive the car 4 miles horizontally and then 3 miles vertically and get the point 4. 3 would set us right on Steve's cabin. Now, if we're talking about the polar movement here, now we actually need this angle right here in order to describe this. And so we'll talk about that in a little bit here, but the angle right here is actually 36.86 degrees. And so when we're describing in polar points, okay, the first thing you're going to have is how far you're going to want this line to be. Okay, so how long is the path that he's actually going to hike on? So if we take a look at this, this is just a right triangle, right? So we know this is 4 and this is 3. So that means that this has to be 5. Okay, so that's going to come first. And then you're also going to use this angle or this rotation that he needs to move off of the what's called a pole in polar coordinates, but you're used to it as the positive x-axis. So this angle here being 36.87 degrees. So if we were talking in polar points, this would be the ordered pair of this exact same spot, Steve's cabin. So 4, 3 in rectangular, and 5 comma 37 degrees if we rounded would be the polar point. So let's go ahead and actually look at what it entails or what makes up a polar point. So the first thing, like we talked about, is the distance from the origin. So how long or how far away is the point in a straight line segment from the origin? We're going to call that R, or the radius. Okay, and then we have how far it rotated off that pole. Okay, in our case, the pole is always going to be the positive x-axis. Okay, so you can kind of think of drawing your grid like this. And then your pole or your polar coordinate is going to start, okay, here at the positive x-axis, and then it's going to rotate a certain amount. Okay, so in Steve's case, okay, it's this is going to be 5 units long, and it's going to rotate 37 degrees, and then it's going to land exactly on his cabin. So we've got a radius and we've got a theta, or an angle that is a certain amount away from the positive x-axis. Okay, so then right there is your theta. All right, so those are the things that you need. So let's go ahead and take a look at a couple of things. So this R, and this will make more sense when we get into like actually graphing some of the points in the next couple of slides. But R can be positive or negative, theta can be positive or negative. You are used to graphing positive or negative angles, remember, okay? So if we were going to graph an angle here, if you wanted that angle to be negative, you would just go down, okay? Or if you want the angle to be positive, you would just go up to start your rotation, right? So this is like negative 45 degrees if we went down that way, okay? Or it would be positive 315 degrees if we went up, okay? Then for the radius, now this one, if the radius is positive, it means you're gonna count out in the same direction as this angle. And again, this will make a little bit more sense on the next screens. So if the radius is positive, you're gonna count along this angle, okay? If the radius is negative, okay, then you're gonna count in the opposite direction of that angle. Okay, so then you're gonna count this way instead of with the angle. Okay, you're gonna count against the angle or in the opposite direction. So let's take a look at plotting a few points here. We've got the polar point 3 and then 120. So again, this is the length of that line, okay? So what I'm gonna do is highlight that with a circle here. So I'm gonna highlight that on our polar graph, okay? So you see all these like little concentric circles here. This is a radius of 1, 2, 3, 4, 5, 6, and so on. So we want this one to be a radius of 3. So this one is gonna be on this circle. This is a radius length of 3. I'm just gonna make that a dotted line here. Okay, so that's all the radii on this circle that are 3 units long. Now we just need to find this angle, okay? And remember that's gonna start off of the pole, which is here, okay? And it's positive 120, so it's gonna go this way to 120 degrees, okay? So there's where our 120-degree angle is. A positive radius means it's gonna count along that line or with that line. So your polar point is right here. Okay, so this has a 120-degree angle and is out 3 units from the center. So let me just move a little bit of this stuff so you can see it. Whoops. Okay, so that point right there is 120 degrees and 3 units out. Okay, so find the radius that you need, and then the angle, and if it's positive it goes along with that angle, and if it's negative it'll go away from it. So in this second example, we've got a radius of 2, so we're going to go out 2 from the center, so we're going to be along this circle, and then we would like to do a 5 pi over 6 angle. So 5 pi over 6 is right here, the pi over 6 reference angle in the 3rd quadrant. So let's go positive all the way over to 5 pi over 6. And then the radius is positive, so it's gonna go along with that angle. It's gonna count out with that angle to 2, which is right on that red circle that I've already highlighted, and there's your polar point. Let's get into an example with a negative. So this one has a radius of 6. So let's go ahead and highlight where the 6 is. 1, 2, 3, 4, 5, 6. So here's the radius of 6 all the way around. And now this time we want a negative 30-degree angle. So we're going to start at the pole and we're going to go down 30 degrees. So 15, 30 degrees. So our polar point right here. Okay, so the negative angle, remember, goes down. You just start by counting down 30 degrees instead of up 30 degrees, or count clockwise 30 degrees if you want to think of it that way. This one has a negative radius. So again, you're just going to count out to 4. 1, 2, 3, 4. Okay, so 4 is the length of it. It doesn't matter that it's negative to figure out how long it is. It's just going to be the direction that you go. So now let's go ahead and find the angle 4 pi over 3. Okay, so we've got 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So now that our radius is negative, okay, so I'm gonna switch to a different color here. Okay, so now with our radius being negative, instead of going out 4 along this angle, right? So instead of going to here, okay, instead of going along that angle, you need to go opposite of that angle. So we need to go backwards, okay, along this same line, okay? So if you were gonna think of extending this line, if you could think of that line extending, you're gonna go backwards on it. Okay, so instead of traveling along with the blue line, we're gonna go backwards from it out to the radius. So that would be the point -4. Okay, so 4 pi over 3 and then -4. All right, then the other thing that I'm going to show you how to do is how to name points that are already plotted for you. So I've got 3 points plotted here. One thing about the rectangular system is that you can have an infinite number of names for one point because it continues to just rotate around and around and around. Unlike the rectangular system where every point is a very distinct spot, you can only name it one way. So let's take a look. Now you only have to be able to name these one way, but I'm going to show you a couple ways so you can see what I mean by it. There's a lot of different ways to name it. So the easiest one, in my opinion, is to just keep everything positive. Okay, so to go over to this point, see its angle. Remember, the angle goes second. Okay, and the radius goes first. So the radius, you just count out 1, 2, 3, 4, 5, those concentric circles. And then you've got your point. And if you need it in radians, you could have used the 3 pi over 4. So that's probably the easiest way to name it. Now, one other way you can name it is by going backwards to the angle. So you could do, if you were going to take and measure the angle this way instead. Okay, so starting here, that's 0, -90, -180, okay, -210, -215. So you could have done that as your angle instead. And then the radius is obviously still 5. Okay, then another way to do it is by using a negative radius. So instead of counting along the angle, so you can use the angle, the opposite angle. So if we had used 315 as our angle, because that's opposite the 135. So if I'd used 315 as my angle, now instead of going out to 5, I'm going back to 5. So instead of counting along this 315 degree angle, I'm counting backwards away from it. So then we would have had a negative radius. And then again, you could have counted back to this angle and used this as -45 degrees with a -5 radius. So again, you do not have to be able to do all of these. So you just have to be able to do it one way. So I would just stick with the positive. It's pretty simple then that way. So let's take a look at naming B. So you go figure out what angle B is at and how far away it is. So for point B, we are at 1, 2 away from the origin. So our radius is 2. And then we are at the angle 270 degrees. Or again, you could get a bunch of different ones. Then point C. Guess I forgot to write B in there, huh? All right, then point C is 1, 2, 3, 4, 5, 6, 7 units away from the origin. Okay, and you can steal 345 since it's written there. You may at this one want to do -15, especially if it's not written out. Maybe you don't want to calculate it, and maybe you know that the width between these is 15 degrees. So you might just want to say the -15 there. Otherwise, 7, 345, or in radians, whatever you choose.